Okay, so we're looking at this problem in chapter 18, number 29. And in chapter 18, number 29, they talk about these two charges, this negative 16 microcoulombs and this positive 4 microcoulombs, and they're 3 meters away. And they want to find the position where these two electric fields created by these charges will be 0. So basically, we don't know how far away it is, so if we assume that the electric field is somewhere in between them, meaning somewhere in between them the electric field is 0, let's call that unknown spot x. So at x, the electric field will be 0. Now, this positive 4 coulombs, remember, the electric fields always point away from the positive and towards the negative. So the electric field of the positive 4 coulombs we're going to draw in blue is going to point towards the left. And the negative 16 microcoulombs is going to point towards it. Remember, the electric field always points towards the negatives, points away from the positive towards the negatives. So this negative 16 microcoulombs is going to point towards the negative 16. Now, if we look at these arrows, both arrows are pointing in directions. It's impossible for an electric field to end up 0 if both these vectors are pointing in the same direction. In order for it to be equal to 0, the vectors have to be pointing in opposite directions. So this is not going to work. Our x is not located somewhere in the center. Instead, we believe our x is located to the right of this positive 4 charge, which is what they want us to find. They want us to find it in reference of the positive 4 charge. So if we block in and we draw our equation, we look at x maybe being to the right of it. And that makes more sense because then you have the negative 16 microcoulombs this way and the positive 4 microcoulombs pulling away. Now that they're pointing in opposite directions, we might be able to make them cancel out. And the blue is pointing away because the charge is positive. The electric field always points away from the positive. And the purple is pointing towards the charge because the electric field always points towards the negative. So then we're going to find E1 and E2, and since we're trying to figure out when they're equal to 0, we know that in this situation we're looking for what happens when E2 is equal to E1. So when we plug it in, we say K times the 16 times 10 to the negative 6 divided by 3 plus X, because that's the actual distance, right? That's how far the electric field is. It's 3 units plus an additional X units apart. Now we use the K Q naught over R equation because we don't know the charge at this point, black point that we created. So we need to figure out the electric field by using the source of the electric field. That's why we use 16 times 10 to the negative 6. This equation that uses K involves using the source. And then we do the same thing with E2. Oh no, forget to square it. Now we do the same thing with E2. We say K 4 times 10 to the negative 6. Again, so we're using the 4 because the 4 microcoulomb charge is the thing creating this electric field at this black point. Divided by the distance from it, which is X units away, squared. Now the reason I know 8K is 8.9 times 10 to the 9th, but the reason I left it as K is because we can pretty much start like canceling these out. So we get like a nice little cleaner equation. Oops, I got a little ahead. So if we eliminate the K's, this is what we get. We gotta remember to square it. And then we can keep working on it. Now since they're both being multiplied by 10 to the negative 6 at the top, I can kind of clean some elimination more. So I can do 4 over x equals 16 over 3 plus x squared. And then we cross multiply. At this point it's just kind of becoming math. We cross multiply. Then we use FOIL to do the 3 plus x squared. And then we distribute the 4. And then after we distribute the 4, we subtract x squared from both sides. So 16x squared minus 4x squared equals 12x squared minus 24x minus 36 is equal to 0. I take out a common multiple. We can all remove 12. So then we get 12x squared minus 2x minus 3 equals 0. And then x squared minus 2x minus 3, we can use algebra to factor things out. And then we can break that down to x minus 3 times x plus 1 is equal to 0. Or we could have used our quadratic equation, depending whichever one you prefer. But whether we use factoring or the quadratic equation, the only way for this to equal 0 is if x is equal to 3 or x equals -1. If x is 3 or x is -1, it's going to equal to 0. But now we're looking at which answer makes the most sense. Now, this both is going to give me the same magnitude. Our real answer is 3, not -1, because -1 would put it in between the -16 microcoulombs and the +4 microcoulombs. That's not going to happen because, like we talked about, you can't. In that case, if it's in between them, the electric field is going to be pointing in the same directions, which is not possible. So the only likely answer is x is equal to 3. So that's the results in E1 and E2 being opposite directions. If we had picked x equals -1, E1 and E2 would have had the same magnitude and the same direction, so it'd be impossible for them to cancel out.